Welcome back to the Rundown Lab, where we break down and fact-check the biggest health podcasts. We know your time is valuable, but when you can, we always recommend catching the full episode. Links are in the description. What if some of the most popular ideas about healing from trauma are built on shaky scientific ground? Today we're taking a closer look at a conversation between Thomas DeLauer and a trauma neuroscientist that covered everything from how our brains process fear to whether trauma can literally be inherited by our children. This episode dives into some genuinely fascinating territory, exploring why some people develop PTSD after trauma while others don't, how exercise affects our mental health, and even whether fascia can store emotional tension. With 17 claims to examine, we found a mix of solid science, reasonable simplifications, and a few ideas that venture well beyond what the research actually supports. Let's start with what the conversation got right, because there's some genuinely valuable information here. The discussion accurately described the brain as a prediction engine, which aligns with the influential predictive processing framework in neuroscience. This isn't just a catchy metaphor. It's a well-established theoretical model associated with researchers like Carl Friston, supported by substantial empirical evidence. The claim that most people exposed to trauma don't develop PTSD is also spot on. Epidemiological studies consistently show that even after severe trauma, the majority of individuals demonstrate natural resilience. Roughly 5 to 10% of trauma-exposed people develop PTSD, though rates are higher for certain types of trauma like sexual assault or combat. The episode also correctly noted that exercise has antidepressant effects comparable to pharmaceutical medications. A large 2023 meta-analysis in the British Medical Journal confirmed this, showing exercise interventions had effect sizes matching or even exceeding antidepressants for depression. And the discussion of exercise increasing BDNF, which supports brain health and memory processing, is generally well supported by research. Now let's get into where things become more complicated. Several claims in this conversation took real science and stretched it a bit too far. Take the discussion of creatine and sleep. There is emerging research suggesting creatine may benefit cognitive function during sleep deprivation by supporting brain energy metabolism. However, the proposed chain of creatine improving energy reserves, which then reduces inflammation, which then produces deeper sleep, that specific mechanism is speculative. Most creatine sleep research focuses on protecting cognitive function when you're sleep deprived, not on improving baseline sleep quality in people who are sleeping normally. The conversation also discussed research on monkeys and snake fear, suggesting that monkeys who've never seen snakes still have an innate fear response to them. This oversimplifies classic research by scientists like Susan Minica. What the studies actually showed is that primates have a prepared learning bias. They can rapidly acquire snake fear through observation, and humans show attentional biases towards snakes. But naive monkeys aren't born afraid of snakes. They're just primed to learn that fear very quickly. That distinction between prepared learning and innate fear matters. Perhaps the most significant oversimplification involves epigenetic trauma transmission. The claim that generational trauma is biologically transmitted through epigenetic modifications sounds compelling. And there is research by Rachel Yehuda and others showing altered stress markers in Holocaust survivor offspring. However, in humans, establishing true transgenerational epigenetic inheritance, meaning changes that pass from grandparent to grandchild without direct exposure, remains extremely challenging. What we observe could be explained by the prenatal environment, parenting behaviors, shared adversity, or socioeconomic factors, not necessarily direct epigenetic inheritance of trauma. Similarly, the discussion of beta blockers preventing PTSD when given after trauma presented this as more established than it actually is. While the theoretical rationale is sound, and early studies showed promise, subsequent larger trials have failed to show consistent preventive effects.
This is not currently a recommended standard intervention. Now for some claims that raised red flags. Two ideas presented in this conversation lack solid scientific support. The first involves fascia, the connective tissue in our bodies. The claim that fascia can take over and cement chronic muscle tightness, potentially trapping trauma-related tension, reflects popular bodywork theories, but it doesn't have robust scientific backing. While fascia does have mechanical properties and contains sensory receptors, the specific mechanism of fascia storing or cementing trauma is more metaphorical than scientifically demonstrated. The second unsupported claim suggests that cross-body physical activities increase neuroplasticity, specifically by promoting communication between brain hemispheres. While bilateral movements do engage both hemispheres and exercise in general promotes neuroplasticity, the specific pathway being described, that cross-body movements enhance interhemispheric crosstalk, which then increases neuroplasticity, lacks direct evidence from controlled studies. This appears to conflate several different research areas without solid support for the specific mechanism proposed. So here's the bottom line. This conversation demonstrates something common in health podcasts: a knowledgeable speaker who accurately presents core scientific concepts, but sometimes extrapolates beyond current evidence. The fundamental ideas about PTSD resilience, the brain as a prediction engine, exercise benefits, and memory reconsolidation are generally well supported. But claims about epigenetic trauma inheritance, fascia storing trauma, and cross-body neuroplasticity overstate or oversimplify what we actually know. The key takeaway? When you hear compelling mechanisms that explain exactly how something works in the body, that's often where speculation begins. The science of trauma and recovery is genuinely fascinating, but it's also still evolving. Being appropriately humble about what we know versus what we theorize is itself a sign of good science.